Okay, so in 11.5, these are going to be additional sections for secondary 2 honors. So basically, you're not going to learn any new formulas, but we're going to utilize the previous formulas in different ways to solve problems and to verify whether things are independent, dependent, things like that, okay? So these problems should be a little bit more challenging, but also sound familiar. So as a review, there's going to be 4 formulas. We've got independent events. This is the formula. If we have the probability of A and B, then that should be equal to the probability of the first event times the probability of the second event. If they are dependent events, then the probability of A and B will be equal to the probability of the first event, and then remember this is conditional, the probability of the second event given that the first event has occurred. Okay, and so I have a couple of examples here, but you can definitely use these formulas in different ways. So just write them down and be familiar with them. The practice problems could have different scenarios. The other 2 formulas are going to be the conditional probability formula, which is the probability of the first event given the second event is equal to when they both happen at the same time divided by the probability of the second event. And then the words and or and or. So if they're mutually exclusive, you can add their probabilities together. If they are not mutually exclusive or inclusive, then remember you add the first plus the second minus when they overlapped. So between these 6 examples, it's a good start, but I do ask things in a different way. All right, so let's look at our first example. It says the probability that it will snow on Sunday is 3/5, and the probability that it will snow on both Sunday and Monday is 3/10. What is the probability that it will snow on Monday if it snowed on Sunday? So what we're really looking for is probability will snow on Monday given it snowed on Sunday. And so we have some conditional probability. So I probably want to utilize this second formula right here, okay? And so we know, like event A, actually we want given A. So A is going to be Sunday, B is going to be Monday. Does that make sense? So let's see, if this is A, I'm going to label the problem. Snowed on both Sunday and Monday, so A and B. All right, so I've got probability of A and B is equal to probability of A times the probability of B given A. And so it says, what is this probability? So this is what we're looking for. So I'm just going to let that be X. The probability of A is 3/5. And A and B, when it happens together, that was 3/10. So see how I'm still using this formula, but definitely in a different way. Labeling the examples to use the same notation of A and B, I think is probably the easiest, but there's lots of strategies. I'm just not one to reason through this though. I like the formula. So in order to solve for A, we'll multiply by the reciprocal. So 5/3 times 5/3. Let's see, that reduces. 5 divides into 10 2 times, so we're left with 1/2. Okay? I don't think these problems are super easy. Logically, I don't follow through, but using a formula, it's pretty easy to derive the answer. All right, let's try our second example. The probability that a student owns a dog is 1/3. The probability that the same student owns a dog and a cat is 2/5. Determine the probability that the student owns a cat. So I'm going to let cat be C, D and C, and then the probability that a student owns a dog. All right, so, well, I kind of have 3 different things, and I don't have any given probabilities, so this is probably a good formula to use. So I've got the probability of C and D. I can change the letters, and that's going to be equal to the probability of a cat times the probability of a dog. Obviously, there could be some more information, but, you know, we don't have it, so we... Okay, so we have I forgot my 1/5 here. 6 over 15, which reduces to be divided by 3, 2, divided by 3, 5. 2/5. All right. Our next problem, given two events, we're not even going to name them. We know the probability of the first one is 0.6, the probability of the second one is 0.5, and A, remember this means or. A or B is 0.8. So we just want to know if these are independent or dependent. So if we look at some of the formulas, we have these, okay? And so if they're independent, we're going to be able to use a formula to see if it's true or not. So if two events are independent, we know this. So I'm going to write this down because this is what we want to test. That P of A and B is equal to probability of A times the probability of B. Now, the issue is that we don't have P and B, we have P or B. So we are going to use this formula to help get P and B. Okay, so I'm going to go down here. So we know that P of A or B is equal to this plus that minus this. Okay, and so that's the same thing. So we need to find that. So we know that P of A or B is 0.8. We know A is 0.6. B is 0.5 minus, we'll just leave this alone because that's what we want to find. So 0.8, this is what, 0.11? No, 1.1 minus A and B. So we'll subtract 1.1, so negative 0.3 equals negative. So two negatives make a positive. So the probability of A and B is 0.3. Okay, so now we want to determine if this equation is true, because then it would be independent. So want for independence. Okay, so the probability of A and B, which is 0.3, so I'll just put check so we know that we're actually determining. Is this equal to the probability of A times the probability of B? Okay, and so we've got 0.6 times 0.5 is 0.3 equals to 0.3, and so the answer is yes, they are independent. Okay, the next question, this is a doozy. Lots of reading, so we're going to use our notation to help simplify it. So we have some contract negotiations, and it says there's a 50% chance that an agreement will be reached on salary. So I'm going to say the probability of salary is equal to 0.5. Then it's estimated there is a 70% chance that there will be an agreement on insurance benefits. So I'm going to say probability of insurance is 0.7. There is a 20% chance that no agreement will be reached on either issue. So what that means is it's the probability of neither P or S is 0.2. So that actually means that not P or S. So the opposite of that would be P or S. Is, remember, our probabilities add up to 1, so if it didn't happen 20% of the time, it's going to happen 80% of the time. So that's 0.8. Okay, so that's kind of the tricky part. Find the probability that an agreement will be reached on both issues. So what we want is the probability of P, why am I saying S? I meant I. I'm so sorry. The probability of I and S, okay? That's what we're looking for. So I kind of need some information that ties this together. So let's look at our options. I've got those. I don't really see a bunch with or, but remember we did have this formula down here. Okay, so A or B plus A, B minus and. All right, so let's go ahead and write that. So the probability of I or S is equal to P of I plus P of S minus probability of I and S. Okay. So what we're looking for is substitution. So we know the OR is 0.8, probability of I is 0.7, probability of PS is 0.5, and then this. I'm just going to let that be X. So 0.8 equals 1.2 minus X. I'll subtract 0.2. Two negatives divide, and so the probability of I and S is equal to 0.4, 40%. And that's what we were looking for. Okay. Now they want to know, second part is they just want to know if the agreement on salaries and the agreement on insurance, is that independent? So remember, for independent events, that was this. So P of A and B, does that equal when we multiply them separately? So let's check. So I'll just go ahead and do this. Independence test. So P of A and probability of I and S is 0.4. Is that equal to the probability of I times the probability of S? Well, this would be 0.35, so 0.4, 0.35. We don't round, and so no, they are not independent. That's what we're looking for. Okay. All right, two more examples. We've got a fast food analyzes data. It discovers the events D, that a customer uses the drive-thru, and F if they order French fries. They're independent, so that's what they're telling us. The following data are given in the report. So the probability of ordering French fries is 80%. The probability of ordering French fries and going through the drive-thru is 0.456. I guess people can still go inside. So given that information, find the probability of ordering French fries given they went through the drive-thru. Okay, and so remember, that's different than and. So it's all the people that are already going through the drive-thru. What's the probability that they will order French fries? So because we have different information, we're going to use the given formula here. So we've got P of F given D is equal to, remember on the top you do when they intersect, so probability of French fries and drive-thru. And then notice the second part is the denominator. So probability of our second part is D, probability of the drive-thru. Okay. Okay, so we want F given D. We know F and D is 0.456. The probability of going through the drive-thru, though, we don't know, so we need to find that information. Now, they did tell us that the events were independent, so remember, that means that this must be true. So the probability of French fries and drive-thru is equal to the probability of French fries times the probability of the drive-thru. So we know F and D. We know F, and so we can find P of D, okay? So if we divide both by 0.8, so 0.456 divided by 0.8 is, P of D equals 0.57. And so that's what we want to plug in here. So P of D equals 0.57. There is no way to logically find that without using the formula. So now we'll do 0.456 divided by 0.57, which is 0.8. Okay, it is a coincidence that those are the same. So definitely not the easiest problems, but remember, we're in an honors class. All right, the last one also sounds super confusing. So a student is chosen at random from the student body. The probability that they select math is 1 out of 4. The probability that the student chosen is a junior is 1/16 out of 459. If the probability that the student selected is a junior or they choose math, so probability of junior or math is this. Then what is the probability that the student selected is a junior whose favorite subject is math? So what we want is the probability of junior and math. Okay, so we need a formula that talks about each of these and the or and the and. So there we go. So we want P of J or M equals J plus M minus J and M. So junior or math, we've got 47 out of 108 equals, the J is this, plus P of M minus P of J and M. Okay, so I am going to go ahead and take those. We've got 47 over 108, and we're going to subtract all of those on the calculator. I'll show what I put in. So let's get my calculator. We'll clear that out. So I want to do 47 divided by 108, and you can type this into just a window on your computer, minus 116 divided by 459, and then minus that 1/4. Oops. Minus 1/4. Okay, now it's going to give us a decimal, which is fine. I can change mine to a fraction. You can also just type as a fraction, but math, and I want to go to fraction. And so there we go. I get negative 31 over 459. So negative 31 over 459. So negative 31 over 459 equals negative P of J and M. So two negatives make a positive. And so this is what I would be looking for. That is the probability that they will like juniors, they will be a junior, and like math. Okay, not a super easy number to guess. Go ahead and give your student practice a try. Have some scratch paper ready, and good luck.